Overclocking used to be easy. Why isn't it easy anymore? Or maybe it is. That's what we're going to find out today. Stay tuned. It used to be that if you wanted to overclock your processor, you would first have to start with, an unlocked processor. And if it wasn't unlocked, you'd have to find a way to unlock it. Kind of like the conductive compound hack for the old Athlon processors, where you had to use CPU compound to short a bridge on the CPU substrate, and voila, you had an unlocked processor. Then, after that, you would go into the BIOS and change your bus speed or your multiplier, or both, and you had an overclocked processor, at least after hours of testing and hours of crashing. I guess it really wasn't that easy, was it? But today, it's even worse because you have boost algorithms and CPUs that don't actually run at the clock speed that they're advertised to run at, because that clock speed is dependent on, thermals and power availability. And you also have to take into account the CCX quality and which cores can boost to what clock speed and which ones can't. Now, you could do an all-core overclock, but if your weakest core can only get to 4.1 gigahertz, but your best core can get to 4.5 gigahertz, then your all-core overclock will be 4.1 because it can only be as high as your weakest core. So now that we have multi-core processors, that you're just not overclocking one core, but sometimes 6 or 12 or 16, and they all can't reach the same speeds. However, believe it or not, as long as you're not doing extreme overclocking and you just wanted a nice little performance boost, there is a really simple way to do it. And that's what we're talking about today. But first, I gotta pay some bills, so check out today's sponsor. Is your copy of Windows 10 unactivated? Well, it doesn't have to be, because with today's sponsor, VIP SCD Key, you can get a valid Windows 10 license for under $20. Stop dealing with that stupid watermark on the desktop, the valid license for Windows 10. Also, with an activated copy of Windows 10, you can upgrade to Windows 11 for free. Just go to the link in the description below and pick up a valid Windows 10 license key. During checkout, use the code CYBERCPU for a 25% discount. Once you have your key, go to your activation settings in Windows 10 and click on the link that says Change Product Key. Enter the product key you just purchased and hit Activate. Now you don't have to deal with that stupid watermark that come with running an unactivated copy of Windows 10. Now, on with the video. Today we're looking at Ryzen Master and Precision Boost Overdrive. This is a way to tweak the AMD boost algorithm to squeeze a little bit more performance out of your system, and best of all, it was all made by AMD and should be very unlikely to hurt your hardware. However, I still have to warn you that overclocking a CPU has risks involved, even if it's only a mild overclock like we're going to be doing today. You do have the potential of using a lot more power, as well as creating a lot of heat. So if you're planning on overclocking your CPU, using an aftermarket cooler is probably a good idea. In fact, the system that I'm doing this on today is water-cooled. However, with all that said, with Precision Boost Overdrive, it gives you the potential to actually be able to undervolt a Ryzen processor as well. In many cases, this can still achieve a pretty decent overclock while giving you more performance while using less power and creating less heat. So it kind of goes both ways. Now, we're not going to be talking about undervolting today, but if you'd like me to do another video on that, let me know down in the comments below. But with that said, let's jump on the computer and see what we can do. Okay, so here we are in Windows 10, and the first thing that we're going to need to do is actually get Ryzen Master. So to do that, we're going to go ahead and open up AMD's website here, and I'll go ahead and leave a link to this down in the description below. If I forget to leave the link, go ahead and remind me. I'm pretty bad about that sometimes. Anyway, once you get to this website, you scroll down to the bottom, and you should be able to download this program. Right here, just go ahead and click the download link and go ahead and download the program. Now, while that's downloading, there's another program that we're gonna need, and it's gonna be Cinebench R23. And I'll go ahead and leave a link to that in the description below as well. But for that, I'm gonna go ahead and just click on download right here, and I'm gonna go ahead and get that downloaded as well. And there it goes. Okay, so Cinebench is going to take a little bit longer to download because it didn't take very long at all. But once we get it downloaded, we're going to go ahead and open up our downloads folder, and we're going to minimize this. Now with Cinebench, we're going to go ahead and right click, and we're going to go ahead and extract this right here. And you can go ahead and extract it into whatever folder you want. This is actually a portable program, so it doesn't actually have to be installed. You can just run it right from the folder that you extract it from. And it's going to take you a minute to extract it because apparently it's compressed pretty well. So while this is extracting, we're going to go ahead and install Ryzen Master. So to do that, you just go ahead and click on the file, and it should ask you for your administrator, user account control right here, and go ahead and hit yes. And then once you do that, it'll go ahead and go through the install process. And it's going to take a minute to get that installed and all of this extracted. And then once we do that, we're going to go ahead and scroll down on the user agreement. On this one, this is one of those license agreements where you have to scroll to the bottom in order to check agree. And then once you do that, go ahead and hit accept and install, and it should install the program. And it's going to take a minute for that to install. And while that's installing, we can check on our Cinebench right here, and it's still taking a little while, but it's almost done. Okay, so Cinebench is done. So I'm going to go ahead and just minimize that and keep it to the side right now, and we're going to get Ryzen Master installed. And then once it's installed, you can go ahead and click Launch Ryzen Master. And go ahead and hit OK to this warning. And of course, this warning is warning you about the dangers of overclocking a CPU. And there are some dangers, but using this program, you're going to be pretty safe. But as long as you follow what I'm doing here, you shouldn't have any problems. And once you hit OK, you're going to be greeted with the basic Ryzen Master UI. What I would recommend doing is switching over to the advanced view right here. And then the advanced view gives you a lot more options. And then from here, you can see all of your different stats for your CPU, including even the CCD information right here about which cores are asleep and which cores are running and what clock speed they're running at and things of that nature. Now, what we're gonna do on this one is we're gonna go over to Profile 1, and that's where we're actually gonna do our overclock. It may make sense just to click Precision Boost Overdrive because that's what we're wanting to do. However, that's not the one we're using because we wanna actually get an overclock on this thing. We don't want just to use Precision Boost Overdrive. We want to actually overclock it a little bit. And for that, we want to click on Auto Overclocking. And then from there, it gives you these 4 different settings that you can change. Now, by default, the PPT, the TDC, and the EDC is all maxed out on my CPU. And depending on your cooling, you can either max these out or maybe you might want to lower them down a little bit depending on if you have any issues. But if you have a reasonable cooling system attached to your CPU, you shouldn't have too much problem. Now, at default, the boost override is only 100 megahertz. Now, what I'm going to do on this one is I'm just going to crank this one all the way up to the max, which is 200. Now, 200 doesn't seem to be a huge overclock, but that's what we're going to do on this one. Now, if you want, at this point, before you actually apply this, you can actually go into Cinebench. You can go ahead and run it real quick. And that's what I'm going to do right here. And then you can go ahead and do a multi-core test just to kind of see how the CPU performs before you overclock it. So you can have some comparison to how it's going to run after you overclock it. And it's going to take a minute, depending on the speed of your CPU, obviously, for this to go through. And as it does this, you might even hear my fans ramp up a little bit. And that's okay. It should be expected because it's using the CPU quite a bit right now. So I'm going to go ahead and jump to the end of this benchmark after it's finished, and we'll go ahead and take note of our score. Okay, so now that it went through, you can see that right now my Ryzen 5 5600 scored a 10,016. So what I would do is go ahead and just note down that number, and then we'll go ahead and jump back in once we restart the system after our overclock is done. And to do that, all we got to do is go ahead and go over here, close Cinebench. We'll go ahead and close this folder here. And then now that we have all of our settings here maxed out, we're going to go ahead and hit apply and test. And once we hit apply and test, it'll go ahead and do a restart on the system. Also, I have one more thing to add that I kind of forgot about. So let me jump on the computer real quick. I got to show you one more detail real fast. Okay, so one quick little detail that I forgot to mention. We're going to go ahead and open Ryzen Master up again real quick here. And there's one setting that you might want to take a look at. Now, this should be set to default on your system. But if you go into settings right here and you look right here where it says write PBO to BIOS, make sure this is turned on. And if you do this, then it should apply this overclock every time you reset your computer, every time you reboot your computer. However, your mileage may vary with this. This may work with some systems. systems and not with others. So make sure you kind of check that out beforehand. If it doesn't work, then unfortunately what you'll end up having to do is actually launching Ryzen Master every time you reboot your computer and applying your overclock again every time. Hopefully it will just apply it for you automatically after every reboot. Now it does work that way with mine on a B450 chipset. So this might have something to do with different chipsets. I know some motherboards don't support overclocking. And if you happen to have one of those motherboards that doesn't support overclocking, you might not even be able to use the program at all to overclock your CPU. However, just keep that in mind that if you go down to the settings, just make sure it says write PBO to BIOS, and hopefully if that one is set, hopefully you won't have to set this each time. You can just set it and forget it. However, like I said, your mileage may vary. Now, back to the video. Okay, so once the system boots back up, it's going to want you to launch Ryzen Master again. And once you get to that point, go ahead and hit yes to the warning screen right here. It should launch the program, and it's going to go ahead and do a stress test now on the CPU to make sure that the overclock that it's running is stable. And as it's doing the stress test, you can actually see what's going on with these gauges up top right here. And you can see my CPU power right now is 96 watts. And that's pretty extreme for a 5600 that's supposed to be a 65 watt processor. So that kind of gives you an idea at what will happen on an overclocked CPU. And also, I'm sitting at 83 Celsius on a water-cooled processor, which is pretty high. However, this is a stress test right here, and this shouldn't be the way that your system normally runs. And now that it's done, it went ahead and tested successful, and the overclock is applied. So now what we can do is we're going to go ahead and open up our downloads folder again, open up Cinebench, and we're going to run Cinebench again real quick. And then once this launches, we're going to go ahead and click start. We're going to go ahead and do the multi-core test again. And then this will kind of give us not only another stress test to make sure that this overclock is stable, but it'll also show us what kind of improvements we can expect from this overclock. So I'm going to go ahead just like before. I'm going to skip ahead until this overclock is done, and we'll take a look at it. And just one note real quick, while this test is running, you can see my temperature down here at the bottom, and it's running at about 73 C. So it's running relatively cool while running Cinebench. So this stress test isn't as stressful, I guess you would say, as the Ryzen Master one, because it's not pushing the CPU as hard. However, once it finishes, we'll go ahead and look at the score and see how much better we did. Okay, so as you can see right here, our new score is 10,411. So we did get a pretty good boost right here for essentially free. Okay, now let's just take a second to talk about how Precision Boost Overdrive works, because a 200 megahertz overclock doesn't really seem that much, but ultimately Precision Boost Overdrive isn't about giving you huge gains in clock speed. In fact, to be honest with you, the days of huge overclocks are pretty much over. There used to be a time when you could get 600 megahertz overclock on a 1200 megahertz processor, but today these dies are all tested and binned by the manufacturer for their silicon quality and what clock speeds they can reach. Obviously, they're not going to give you a 3.5 gigahertz processor, a core that's binned at over 5 gigahertz, because they'd rather sell more 5 gigahertz processors. I mean, they're over double the price in some cases. However, in some rare cases, you might actually get a core that is binned at 5 gigahertz simply because they ran out of lower bin cores and they needed to increase the supply of 3.5 gigahertz CPUs. But don't count on it. High bin cores are kind of rare, and that's why those CPUs cost so much to begin with. But with that said, this binning is why you're likely not going to see a huge overclock like we did in days past, without simply getting super lucky and getting an absolute Goldilocks chip. Because of this, our goal isn't to achieve bragging right overclock numbers, but rather our goal is to be able to reach our maximum clock speed and stay there for the longest time possible. And that's exactly what we're doing with Precision Boost Overdrive. Because from the factory, Ryzen CPUs are kind of detuned to be able to run consistently regardless of your motherboard, your cooling solution, your power availability, scalability, and all of those other aspects. Because the last thing AMD wants is a bunch of people complaining that their CPUs are unstable because they're using the stock cooler. So AMD just detunes the boost algorithm to run great with the stock cooler, as well as being able to reach their advertised power ratings while making the CPU as stable as possible. Because chances are your CPU can reach higher boost clocks and stay at those boost clocks for considerably longer while still being stable, especially if you have a good cooling solution and decent power delivery. So, with all that said, now that we have a Precision Boost overdrive configured on this system, let's see some benchmarks and see how it runs. The first benchmark we're looking at is Cinebench. I have some game benchmarks coming up, but I wanted some CPU specific benchmarks just so we can see how much improvement we get out of our overclock without having to worry about GPU and CPU bottlenecks. With the CPU at stock, we got a multi-core score of 11,105. Now, you might say that that's considerably more than what we got in the screen recording earlier. And you also have to remember that at that time, I also wasn't screen recording and wasn't running other programs in the background. So that was actually a fair benchmark. What you saw earlier wasn't really a fair benchmark. It was more of a crippled benchmark because of the things running in the background in order to make the video. Now, once overclocking with Precision Boost Overdrive, we got an 11,490. That's a 3.4% improvement from the factory clock speed. And as you can tell, it's about the same difference that we got with our crippled benchmark that we did earlier just to test stability. Now, while I was in Cinebench, I went ahead and played around a little bit and did a manual all-core overclock and was able to get it stable at around 4.55 gigahertz with just a little bit of voltage. I was also able to get it to run pretty consistently at 4.5 gigahertz while undervolting, pretty considerably actually. But at my highest overclock of 4.55, I got a Cinebench score of 11,651, which gives us a 4.8% improvement from the stock clock speed. That's actually not too bad of an improvement for such a small overclock. Now, the next benchmark we're looking at is the 3D Mark CPU profile. With the stock clock speeds, I got a max thread score of 5684. Once applying the Precision Boost Overdrive overclock, I got a max thread score of 5847. That gives us a 2.8% improvement from the stock clock speed. Not quite as great as an improvement as we saw in Cinebench, but still a pretty good improvement. The next benchmark I did was PC Mark. The results to this benchmark were kind of interesting. With the stock clock speed, I got an overall score of 6757. But once applying the Precision Boost Overdrive overclock, I got an overall score of 6849, which is only a 1.4% improvement. However, that's not the part that's interesting. Once we broke down the scores into all the different categories, we actually lost 0.5% on both essentials and content creation. However, it was such a low drop that it's well within the margin of error. However, when we look at the productivity score, we actually got a 5% increase in performance. This would be programs like Word and Excel and things like that. So it seems like Precision Boost Overdrive seems to help pretty good when it comes to Office apps. My game benchmarks are going to be a little bit different than I typically do because I had a requirement in order for a benchmark to qualify for this video. Because we're testing the CPU overclock, the game had to have at least 40% or higher CPU usage during the benchmark, or it wouldn't even make sense to include it in the video. The first game I'm looking at is Counter-Strike 2. This game was ran at 1080p with the graphics set to medium, so I could get as much processor usage as possible. On the stock clock speed, I got an average FPS of 330.7 and a 1% low of 149.5. I also got a 0.1% low of 59.3. Now, once applying the overclock, I got an average FPS of 332.4, which is only a 0.5% improvement from the stock clock speed. However, my 1% low was 155. That's a 3.6% improvement over the factory clock. And the 0.1% low was 66.2, giving us an 11% improvement from the factory clock speed. So our overclock didn't give us a huge benefit in average frame rate, but it did benefit our frame timings quite a bit. The next game we're looking at is Cyberpunk 2077. Now this game hit the processor the hardest from any of the games that I tested. I also lowered the resolution to 1080p and set the game to medium graphics settings. I did, however, enable DLSS because I thought that would increase the CPU usage, and it looks like it did. With the factory clock speed, I got an average FPS of 143 and a 1% low of 95. The 0.1% low was 81.5. Once applying the overclock with Precision Boost Overdrive, I got an average FPS of 145.1, which is only a 1.5% improvement and well within the margin of error. However, like the last game, once we got to the 1% low, that was 106.3, which is an 11.2% improvement. And the 0.1% low was 91.1, which is an 11.1% improvement. So while the overclock didn't help our average frame rate much, it definitely helped our frame rate consistency by bringing the 1% and the 0.1% low up quite a bit. The next game we're looking at is Red Dead Redemption 2. Just like in the other games, I ran this one at 1080p with the graphics setting on the highest low setting. I also made sure to enable DLSS on this one to help CPU usage, but it wasn't anywhere near as high as Cyberpunk. It averaged around 60 to 70% during gameplay. At the stock clock speed, I got a 107.9 average frame rate and a 1% low of 78.7. Our 0.1% low was 55.1. Once overclocking the CPU, we got an average FPS of 113.1, which is a 4.7% improvement. Our 1% low was 83.3, which was a 5.7% improvement. However, the shocking result here is once we get to the 0.1% low, for that, we got a 49.7, which turned out being a 10.3% loss in performance. Now, this is the first game that actually saw a pretty good improvement on our average frame rate at 4.7%. But we took a hit in our 0.1% low. Now, a 10% hit in our 0.1% low actually isn't that bad. And the 4.7% improvement on our average frame rate is actually quite good. The only thing I can think of is that I do know that Red Dead Redemption 2 can be fairly unstable when using an overclocked GPU, and that might be the case with an overclocked CPU as well. However, I didn't get any crashes and I didn't notice any stumbling or inconsistencies in the frame rate. The next game we're looking at is Shadow of the Tomb Raider. I haven't used this game in a while for benchmarking, but this game definitely pushed the processor once I set the game down to 1080p and set all the details to medium. With the processor and its stock clock speed, I got an average FPS of 161.8 and a 1% low of 127.1. I also got a 0.1% low of 67.4. Once overclocking the CPU, I got an average frame rate of 160.3, which is actually a 0.9% drop in frame rate. However, that's well within the margin of error. My 1% low was 139.4, which is a 9.2% improvement from the stock clock speed. And my 0.1% low was 134.1, which is a 66.2% improvement from the stock clock speed. So we didn't get any improvement from our average frame rate, but we did get a lot of improvement on our frame timings, giving us a much more consistent frame rate. I mean, our average frame rate was 160.3 and our 0.1% low was 134.1. I really like frame timings being that close to the average frame rate. That gives us a pretty smooth and consistent frame rate. So, I have no doubt I was going to see some improvement with an overclocked CPU. I just didn't know how much improvement that would be. Because here's the thing, I'm using a Ryzen 5 5600 and an RTX 3060. Neither the CPU or GPU have to worry about thermals because both of them are water cooled behind a 360mm radiator. Also, the CPU and GPU are very well matched, so I really don't have any bottleneck problems between the two. However, if I installed a 3070 or a 3080 in the same system, I would probably see much greater improvement because at that point, I would start seeing a bottleneck in my CPU. And at the same time, if I put a GTX 1660 in the system, then there wouldn't see any improvement at all with an overclocked CPU because at that point, I'd be GPU limited. So your mileage is going to vary when it comes to overclocking your CPU. It's all going to depend on where your bottlenecks are at. If your CPU is over-spec'd for your GPU, then you're not going to see any improvement at all. But if your CPU is fairly underpowered to your GPU, then you're going to see a lot of improvement. Ultimately, in gaming, your CPU has to control the world thread. It has to deal with NPCs and throw frames at the GPU. As long as it can do that efficiently, you're not going to see a huge improvement by increasing your clock speed. But if your GPU is sitting around waiting for your CPU, then you're going to see a lot of improvement from overclocking your CPU. But here's the thing. Some of the downsides to this, though, is that when you run a processor over its factory clock speed, it starts to become fairly inefficient. My Ryzen 5 5600 has an advertised TDP of 65 watts. However, while I was overclocking it, I was pushing 95 watts. That's closer to the wattage of a Ryzen 9 5900X. And I've got quite a few less cores than that processor. Now, that's fine because I have plenty of cooling capacity for 95 watts. During that whole time, it never really went over the 70s, except for, the stability test in Ryzen Master. But it also has to suck that power out of the wall. So just keep in mind that if you decide you want to overclock your CPU, it's going to definitely use more power. That is unless you're undervolting, but we're going to cover that in another video. Like I said before, if you want me to cover undervolting, then let me know in the comments below, and maybe I'll do a video on that one. In fact, I might end up doing a video on that one anyway, just to cure my own curiosity. But now that we've covered the CPU, if you're looking for a video on how to overclock your GPU, then check out this video where I show you exactly how to overclock the same RTX 3060. Maybe I should do both of them at the same time and see what results we get. Maybe let me know in the comments if you'd like to see that video too. As always, you guys have a great day.